All right, so what we're going to be talking about today is systems of equations. We won't get to the inequality part. The inequality part will be tomorrow, okay? So you guys already know how to solve systems of linear equations. You did it in 9th grade. You did algebraic and you did it graphically, okay? So this isn't new. What's going to be new about it is we're going to start talking about systems of equations where you're dealing with a quadratic and a linear. Quadratic is a parabola, right? Okay, so you guys are going to learn how to do those as well. Are we ready? Okay, so let's look at the first one. We're going to solve the system of equations below, then we're going to graph the two equations on page 1.3. I actually added an algebraic page, so this should say 1.4. Sorry about that. So what we're going to do is on the next page, we're going to solve this out algebraically. Are you ready? Get a marker here somewhere. Okay. So they're both y equals, right? So when we're talking about systems of equations, what kind of answer are we looking for? Does anybody remember? What kind of answer are we looking for when we're dealing with a system of equations? Do you guys remember solving it graphically? Do you remember 9th grade at all? No? Okay, so we're going to pretend like it didn't exist and we're going to start from scratch. Okay, so y equals and y equals, right? If they're both y equals, what can we do? Good, we can set them equal to each other because what's y equal to? Y. Okay, so we can take these and we can set them equal to each other. Okay, so 2x plus 4 equals negative 3x minus 1. Good. If they're both y equals, we set them equal. You guys also did substitution and elimination in 9th grade. Does that ring a bell? Okay. Okay, so now what am I going to do? Get what to one side? The x's. Good. So what do I want to move? Sure, let's move over that negative 3. So I'm going to add 3x to both sides. We get 5x plus 4 equals negative 1. Okay. Subtract 4. Good. 5x equals negative 5.
Oh my God.
X equals negative 1. It's quick. Be nice to one another. Be nice to one another. We all love everyone. I love everyone. We all love everyone. I love everyone. Love. Okay, so we have x equals 1, right? Negative 1. Thank you for the correction. Okay, but that's not all I need. What else do I need? I need the y. Very good, because when we solve a system of equations, what we're looking for is the point that they share. Okay? When we go and graph this, what you're going to see is the two lines are going to intersect, and the solution is their point of intersection. Okay, so we need my solution to be written as a point. So we're going to start by taking my point and putting in the x value. I know what that is. Okay? I need the y value. How do I get it? Absolutely. Doesn't matter which one I substituted in for. No, pick the easy one. That's like key. Okay, so I'm going to choose the first one. Y equals 2x plus 4. And I'm going to plug in that negative 1 for my x. And I'm going to get 2. Where am I going to put that 2? Yeah. What do I have to remember to do? It starts with a C. Check. Do I have to check it into one of the equations or both? Both. Okay, so y equals 2x plus 4 is my first one. So y is 2, x is negative 1, and we get 2 equals 2. That one checks. Okay. Next one I'm going to check is the y equals negative 3x minus 1. Y is 2. X is negative 1. So we get 2 equals 3 minus 1, which is 2. So that checks as well. So this is my solution. I don't really need the curly brackets. but I wanted to make sure you knew what the solution was. Do I ever circle or box anything? No. No circling, no boxing. Okay? That's my solution. Do you guys know why we don't circle or box? Yeah. Right. If you circle the wrong answer and you have the right answer to the right of it, but you circled the wrong one, I can't give you any credit. Okay, so you have to make sure that you do not circle or box. Cassandra, are you going to circle or box anything? Good girl. Okay, so how do we feel? You okay with that? I'm waiting. I'm sorry. Okay. Okay, so let's give this a shot graphically. All right, so we're going to graph the first one. That's 2x plus 4. I'm going to graph the second one. Control G to bring back up your function bar. Negative 3x minus 1. And we see the intersection, right? The intersection point is my solution. Who knows how to find the intersection point on the calculator? Nope. That's too hard. Easier, please. We like easy. Kind of. I'm going to go where? Menu. I don't want analyze. Nope. Geometry. Yep. This is the way you want to do it. Menu, geometry, points and lines, and I want and the reason we use this intersection points versus the other one is if there's multiple intersection points, this tool will bring up all of them. With the other one, it's only going to bring up one. Okay? So click on one, then click on the other, and the point appears, negative 1, 2. Is my intersection point the same as my algebraic solution? Yes, it does. Okay, so how is the point of intersection related to the algebraic solution? It is the solution. Okay? The point of intersection is the solution to the algebraic system. Point of intersection is the solution to the algebraic system. I hope you guys can read cursive. Point of intersection is the solution to the algebraic system. So graphing and finding the intersection point is a great way to check your work. Okay? You could also use a calculator page, store X, store Y, and type in, and it'll say true or false. That's also another really nice way to do it. Okie dokie. Yep, use your tools. Don't spend more time than you need to. Are we ready? Okay. Gabby, good? Okay. I don't want to get yelled at again. Okay, so let's try a linear quadratic system. What's a quadratic? Parabola. Okay, it's got an x squared. All right, so we're going to try it graphically to start. And the reason we're trying it graphically is because a lot of time quadratic linear systems, you're not going to get pretty solutions, okay? We haven't learned the quadratic formula yet, which we're going to learn probably in a couple of weeks. When we learn the quadratic formula, then you'll be able to solve any quadratic. But for now, we're going to stick with graphically. So I've got x squared plus 3x plus 2. And I've got negative 2x plus 1. Okay, so on the next page, I have graph page. Go ahead and graph them. You know what? I'm going to make somebody else run the class for a little while. Capture. Let's see where everybody is. Look how fast you guys are. I'm going to have this person. I don't know who it is. It's him. Okay, so we've got our quadratic linear system, right? How many solutions do you think it has? 2. I have a problem, though. What's my problem? I can't see the other one. I need to see the other one. I can change the numbers. What else can I do? Great. I can come up here to my upper second quadrant, and I can grab that paper and pull it down so that I can see both solutions clearly. Good. Click to let go, or hit escape. Okay, so now I can do what? How do I find the points on the calculator? Menu, geometry, points and lines, good. Intersection points, great. Am I buffering? Okay, he clicked on one, then he clicked on the other, and they both popped up. What do you notice about these points? Yeah, they're ugly, right? They're decimals. That's okay, because in real life, you get ugly solutions. You get decimals, okay? So you got to get used to that. So this was a very quick, easy way to find my solutions graphically. So if it was a multiple choice question, would you solve it out algebraically? You would just throw it in your calculator, graph it, and find the solutions, okay? So the way you're going to write your solutions, because there's more than one, we use curly brackets. Sure. Yep. Menu, actions, text. You find it? Okay. So menu, actions, text. Are you putting it in text box? Okay. Yes, I didn't see the negative sign. I apologize. Okay, so he opened a text box, menu, actions, text. He clicked anywhere in an open space, and he's typing in his solutions. Nice job. You put the first point, so comma, 10.6. And then outside of that parenthesis, comma, open another parenthesis, and put the other point. Okay, hit enter, and it'll stay. Great. Okay, so those are your solutions. Okay, so you guys pretty comfortable with doing it graphically? Pretty easy, right? Okay, so here's our next one. That's fine. So I've got 50 equals x squared plus y squared and y equals x. So now, are these both y equals? No. So can I set them equal to each other? No. So, well, I can, but that'd be way more work than I need to do. What are my other options for solving systems? I don't have to just set them equal to each other. What else can I use? Starts with an S. Substitution, right? I have y equals x, don't I? So what can I do? Yeah, what does y equal? It equals x, so I can use that information, okay? So on the next page, I think I have this set up, yep. So here's my equations, right? So what I'm going to do is I'm going to take y, or I'm going to take x, and I'm going to plug it in for y. So we get 50 equals x squared plus, what am I plugging in for y? X squared. Okay, so I get 50 equals x squared plus x squared. Because all I did was, it's telling me y equals x. So what can I plug in for y? X. I could have plugged in an x for the y, or a y in for the x. Doesn't make a difference which way I go. But this is probably the easiest way. Okay, so now what do I do? Yes. How? They combine to be what? 2x squared, good. 50 equals 2x squared. Absolutely, divide by 2. So 25 equals x squared. Yep, what's the square root of 25? Now be careful. Remember in trig, I said when you take the square root, it always has to be good, plus and minus 5. Okay, you have to have both solutions. That's going to be really important. Okay, so now we're starting off with knowing that we have two solutions here. We have one with a 5 and one with a negative 5 as my x values. It's in the book. Okay, so I've got half of my solution, right? I need to find what values. Which one am I going to use, the first equation or the second equation? Yeah, the second one's easy, right? Y equals x. Well, what does x equal? 5, and what's x also equal? So what does y equal? Okay, so if x equals y, that means y equals x. That means they have to be the same. That's it. Okay, those are my two solutions. Does anybody know what this is? 50 equals x squared plus y squared. Does anybody know what that is? What is it? If I were to graph it, what would it look like? I guess that's what I want. Anybody know? It's a circle. Awesome. That's a circle. X squared plus y squared equals 50. Where's the center of the circle? You should know this from last year. Where's the center of the circle? Am I adding anything to the x or y? Right. Center is at the origin. Okay. What's the radius of the circle? No. No. Center is 0, 0. The radius, square root of 50. Okay. So 5 squared to 2 when we get into reducing. Okay, so that's just a little side note. All right, so basically what we were looking at is a circle. That's the worst centered circle about the origin I've ever seen. Is that better? Not really. We can pretend. It's an oval. I'm sorry. I'm terrible at circles. Okay, and the line y equals x is a diagonal straight through the origin. Okay, so my solutions are here and here, which makes sense. 5, 5, negative 5, negative 5. Okay. Are we all right? Can I make it go away? Okay. All right, so we're not going to do that one graphically. We're going to move on to the next one. This isn't that hard. It's not. This is what I know. It's not that hard. Trust me. Just put your faith in me for a moment, okay? Just a moment of faith. Just a moment of faith. Because it's in a question format. Only I can do that. It's my little piece of only I can do heaven. I'm sorry. Okay. So if you look at that kind of piece, if you look at this, that's a rational equation, right? We just got done dealing with these. I don't really like it because it's kind of ugly, yeah? But what can I do? That's not. Think about rational equations. What do we generally do? What do we generally do? What do we generally do? We generally cross multiply. If I cross multiply, what do I get?
You get y equals x squared minus y.
Beautiful. Okay. So now I have a y equals, and I have a y minus 3 equals x. What do you think I should do here? I could use substitution right away, right? Because I know what x equals. But what would I have to do if I did that? I'd have to FOIL. And I don't want to do that. So let's make it easier on ourselves. What could I do to this second equation? Yeah, let's solve it for y. Let's add over that 3. Good. That makes it a little bit easier, right? I added the 3. Just over to the other side. Yes, ma'am. Okay. Okay, so now I have a y equals, and I have a y equals, which means I can do what?
Y equals
Set them equal to each other. Yes, set them equal to each other. Okay. All right. Now what? I'm going to move the x over. What else am I going to move over? Why am I moving everything to one side? Because it's a what? What kind of function is this? Quadratic. Generally, when I have quadratics, I like to get everything to one side so I can do what? Factor. Quadratic. It's a parabola, has a squared. Anything with a squared that starts. Yeah. Okay, now what? Factor. Okay. Are those my answers?
No.
Why not?
Wait, I said two. You already do it
Uh-huh.
already?
I can have lots of solutions. I can have negatives.
You can only have one out.
I can have two x's.
Oh.
Remember, I'm dealing with a quadratic, right? And a linear. How many solutions do I have? Two. So I have to find the y's. Thank you. Okay, so you have your x values. You need to find your y's. How do we find your y's? Which one should we use? Which equation? Probably this one would be the easier one, right? So y equals 4 plus 3, or y equals 7. So that's going to go with my 4. Y equals negative 3 plus 3, or y equals 0. So those are my solutions. Are we good? For right now, I could lie to you and say this is as hard as it gets. Would you like me to lie to you? Okay. Johnny, this is as hard as it's going to get. Caitlin, it's going to get harder. Okay. Not right now. Right now, we're going to stick with the ones that are factorable. But sometimes you get ones that aren't factorable. And then we start talking about something called the quadratic formula. We're going to talk about that in a couple weeks. And it's a formula. Not right now. Okay. Can I make it go away, guys? I'm waiting. Okay. All right, so we could graph it. What I'm going to do is I'm going to skip that for right now because I want to talk about something else. Before we get into systems of inequalities, I want to talk about quadratic inequalities. We didn't talk about this before. We talked about absolute value inequalities. We talked about regular inequalities. We haven't talked about quadratic, okay? So we're going to do a little side note. So you can either add a notes page to your calculator or you can put this in your notebook. It's up to you. Okay. Quadratic inequalities. And these are important. New York State won't allow it. I'm very sorry. I know, it's very stressful. I know. I'm sorry. Okay, so the first one we're going to look at is x squared minus x minus 12 is less than 0. Ultimately 0. Okay, x squared minus x minus 12 is less than 0. All right, so if this was an equation, how would I solve it? factor. Very good. How does it factor?
X minus 4.
Beautiful. Okay. So now here comes the trick. Okay? When you're dealing with quadratic inequalities, what we wind up doing is we get two possible solution sets. All right? And then we have to decide which one works for us. So here's what you do. Are you paying attention? Okay. Okay. So you're going to take, we know the next step is to set less than 0, right? So you're going to do your first one normal. X minus 4 is less than 0. The next one, x plus 3, you're going to make that greater than 0.
Why is it still nothing?
Because it's like absolute value inequalities. But here's the trick. Or. And then you flip. X minus 4 is greater than 0. X plus 3 is less than 0. Okay, I switched it around. It's just how we have to deal with them. Bear with me. You'll see in a second, okay? So we can real quick say x is less than 4, x is greater than negative 3, x is greater than 4, x is less than negative 3, right? That's just solving for x. All right, so we have two possible sets. Here's option 1, here's option 2. Okay, we need to decide which one works. So here's how you're going to decide. You're going to do something called a test point. Okay, and we're going to make the test point really easy. We're going to make the test point be 0. 0 is the easiest test point to use because 0 times anything is. Okay, so what I'm going to do is I'm going to take that test point and I'm going to plug it into the original equation, or inequality, sorry. 0 squared minus 0 minus 12 is less than 0. All I did was plug in 0 for x. So what's 0 minus 0 minus 12? Negative 12. We agree? Is negative 12 less than 0? Yeah, absolutely. So that's a true statement. Okay? So this is going to help us to figure out which one is our solution. So now my test point was x equals 0, right? So is x part of my solution? Yeah, because it was true. Okay, so 0 has to be part of my solution. So we have to decide which one of these includes 0. X is less than 4, x is greater than negative 3. Looks like this when we graph it, right? This one, x is greater than 4, x is less than negative 3, looks like this. Which one of these solutions includes 0? First one. So this one is going to be my solution. Okay, so my solution and all I did to go from here to here to rewrite it, right, is it's eating the 4, it's eating the x. You just got to keep your signs the same way they were originally. We okay? Yeah, we're going to do another one. Okay. X squared minus 9 is greater than or equal to 0. So first step is to do what? Factor it. So go ahead and factor it. That should be quick, right? I just wrote it down. X plus 3x minus 3 is greater than or equal to 0. Good? Now what? So tell me what to write. Awesome. Or, good. Awesome. Okay, so it's either going to be x is greater than or equal to -3, x is less than or equal to 3, x is less than or equal to -3, x is greater than or equal to 3. How do we figure out which one it is? Through that test point, right? Test point is 0, so 0 squared minus 9 is greater than or equal to 0. Is -9 greater than or equal to 0? That's a false, right? So 0 cannot be part of my solution. So x is greater than or equal to 3, -3. X is less than or equal to 3. Is 0 included there? Is 0 greater than -3 and less than 3? Yes. So we reject because 0 is included in that. 0 can't be part of our solution. So this is our solution. Okay? So x is less than or equal to -3 or x is greater than or equal to 3. Okay, so we plugged in 0, right? And we said that -9 is not greater than or equal to 0, right? So 0 cannot be part of our solution. You just told me that 0 was between -3 and 3. So that means 0 would be part of this solution, which we know it can't be. So it has to be this one. If you look at it graphically, which may be easier for you, -3, +3, right? 0 is right here. It's part of the solution. Can it be part of the solution? No. Okay, this one, it's going to go this way. It's going to go this way. Is 0 part of that solution? No. So it's going to be this one.
Is 0 always going to be the...
Yes, always use 0 for your test point. It's the easiest one to use. You can use other values, but why? If you can't write it, like normally we like to have things written like this, right? But we can't with this one. Because if I were to put the -3 here, now what is it eating? It's not eating my -3 anymore. Okay, so you can't do it that way with this one. Okay, we're good? All right, no homework tonight. I do believe your test is going to be pushed back probably till Tuesday of next week. Wednesday of next week. I will be here. Right. So your test will be on a day that I'm not here. So what we'll do is we'll review Friday. We'll review Monday. You're going to have 2 days of review. Okay? And then your test will be next Wednesday. So I'm pushing it back. Everything that you've learned so far this year. Yeah.